Hi, good day. This is Man, Serverboy UK. Today I built myself an application, small app, which is to convert lux, it's like the amount of light when you use a light meter, to aperture for photography. I am a photographer also, and obviously you could get a synchronic light meter, which when you do incident light in studio, you get your aperture setting for certain ISO and f-stop, but that's quite expensive. And I was thinking that those cheaper light meter, which only measures the amount of light and give you lux reading, LUX, would that serve the purpose also? Of course, I haven't tried honestly, but it might be a little less precise, not calibrate well, and that sort of thing. So I went up to Wiki and search around and see how to convert lux to EV and then to aperture stop for certain ISO and things like those, and test different formulas, and then come up with a formula that seems to work alright with a certain possibility of doing it. And then the next thing is to build an app to convert it. When I got the lux reading, then I could do it and come up with the aperture setting. Now the outcome is in the test script here, the second line. I basically just build it. Of course you could build it with a spreadsheet, but I built it with a Cloud Function on GCP, which is running here with a trigger, and this is the trigger, HTTP trigger. So I use code to send the post to that Cloud Function with a aperture stop of 1/200, a lux reading of 10,000, and ISO reading. When I set I was thinking, I set my ISO to 100 for say studio shot. Alright, then I got, and when I run it just now, what I did, I could do it again. When I send it over to the function, it come up with 4.0, which is the aperture reading, f4. So that's basic idea. Say if I change the text to say the lux is now 5 instead of 10,000, it's 5,000, and what will it do? It would give you 2.8, which is about one stop lower or higher up in the aperture, so you got a bigger aperture for less amount of light to compensate. That's correct, right? And then that's the idea. So just how is it written up? So let's see. I have the index.js, which is the core muscle of just a simple app to calculate, and this formula is right here. It's basically the square root of blah 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 blah. You could look at it. This 12.5 is when I look up wiki on this light meter thing, it is a coefficient. It's basically the calibration thing. Different sensors have different coefficient. This is the way I learned about it. And I guess when I actually finally get my lux meter, I will have to calibrate a little with a baseline. I don't know where I get the baseline. Might be my camera meter, might be my eyes, but then regardless, that's a tuning excuse me, tuning parameter, and this divided by 5 is that metric which I deviates a bit from the wiki. You could look up the wiki. It's well documented formula, math, but they didn't say this divide by 5. And then when I got it, I tried different combinations, and somehow I have to divide by 5 to get the correct aperture. Fortunately, it seems to be linear, so that's fine. All right, and since the post is obviously when you look at it just now, is JSON, so I was thinking I just pass it into float. I didn't do much. Oh yeah, I did have a try and catch. So if there's an error here and there, then hope that it will catch it and send an error code back. And then when the calculation's done, I want to get it to 1 decimal point and send back the result with a 200 HTTP code. And that's it. That's the basic function. Well, function, right? Google Cloud Function. So the cloud build, YAM is very simple. I was trying to build a test function to test it before, the pipeline thing. It's a CICD pipeline setup, and I basically host it up to GitHub. GitHub is where it's my GitHub here. It's my GitHub. You could take a look from here, and then the project is node 1, and yeah, that's basically here. And when I submit it, when I commit it would trigger a build. Obviously, it would trigger a test also, but there's no test function. I'm not good at building test script yet. So there's no test script yet. So I would build it later, perhaps with the Mocha package, which I saw just now, which could describe, you could pump something in it and try it out. And I also was using the Google Cloud build environment to do local tests before submitting. So that's one step of doing it. Okay, back to Cloud build. I'm sorry. Let's go back to Cloud build. And then, okay, the deploy, name of function. I use a sample from internet, and then the use CICD function, you could put a different name, doesn't matter. And trigger it by HTTP. Before then, I didn't have this allow an authenticated parameter. So once deployed, when I want to trigger it from internet instead of from within Google Cloud with VPC or whatever, it doesn't let me to access from internet. It's obviously a security concern, so it's good. So I'll show it later. We actually add a rule in the Google Cloud environment for the function to allow internet access or public access. And then later I figure out that maybe I could use this allow an authenticated parameter when I build it, and it would do the magic without me having to add that parameter, add that permission every time. We'll see. The trigger point is called cloud aperture, which is this function exports.cloud aperture. Alright, that's the idea. So then you might ask why you do all this clumsy thing. Why not just build it within that Python script or JS, Node.js kind of thing, then host it somewhere. The whole idea is, I think Google Cloud Function is supposed to be for the scalability. Say if this function is accessed by a burst of traffic, suddenly many photographers are doing it and they like my function, and then the traffic jump up. That the whole idea of Google Cloud, if I pay for it, is that it scales with the need of that usage of function. So if I host it myself, my hosting might not have that scalability. At the same time, when scalability in terms of cost, so it's not linear to the amount of traffic to so essentially I need to my backend is now on a gigabit link, so it therefore is certain RAM, blah blah blah, and so it doesn't. I think that that obviously is one key reason for a managed cloud environment with, say, GCP or AWS. And even yourself, if I could scale up myself with that sort of thing, I probably could. That's all come down to your baseline, your cost and benefit proposition. Okay, so let's go to this cloud thing. Here you go. Let me reduce the screen a bit, put it over there. Alright, here you go, and let's go to the trigger. The trigger, the CI/CD workflow makes it easier. CI/CD, sorry, make it easier for me to just git commit and then they trigger the build. I find it useful when I have a complicated sequence of work to do the trigger, and when a team are doing it, but not very useful when I'm doing alone. So, but anyhow, it's a good illustration of how it could be done in a CI/CD environment. So set up a trigger like that, and then hit edit it. So basically it's the name, the trigger, when I push to a branch on my GitHub. So it's a GitHub source, and the branch name, and yeah, that's it. It could require approval before build, but I don't need it. Now, one thing I don't quite like is at the beginning, I think it doesn't support GitLab. There are different types of GitHub is just of course, it's a very popular GitHub environment in the world, but I obviously could run my own GitHub on my host facility. I could use different Git compatible protocol with like GitLab in UK. So I would expect that I could specify repository with a compatible protocol rather than a repository with a certain brand name. But that's how life is. So I actually host my other projects in GitLab. Then now, because of these things, I have to move to GitHub a little more. Okay, so with the trigger, then when I commit, it would trigger the build, and I could actually see the build going on. It takes about 30 seconds to a minute or something for a little tiny thing, and then it would create a cloud function. Now let's see what the cloud function is. Here we go. So that's the cloud function. When I click on it and look at the trigger, and here's the trigger name. So it's a URL, and I just use this URL in my where is it? In my curl. Here you go. That's the URL, same one, and that's it. It's just like any HTTP request. And the permissions, initially I added these all users here. It is not there by default, probably because my earlier build it didn't have this this setting here. Probably because I didn't put allow unauthenticated there. So yeah, but I guess it's always good to have protection by default rather than to open up by default. So it's good. Now, and plus that, it seems to me that this is cloud function, but it seems to me that when I read up, Google Cloud Platform likes to have more permission, more flexibility in permission, opening up endpoints using Cloud Run. Cloud Run is more it's like you can put multiple functions in a container. It's more like a bigger, fuller scale container kind of thing. Whereas Cloud Function is in the microservice architecture. It's more like you write a small function in any code and run it in the cloud. It's very immutable, self-contained, no state, stateless object. Carl run is more you see the container concept there, and you could manipulate a little more with different functions, that sort of thing. So depends. And the source, that's the way it is when it's basically it grab everything and it build it in there. You could see the logs. One thing is not, maybe I am at a very low tier since I don't have a big budget, but it's a little slower. Sometimes it is not like keeping in pace with my development pace, that I have to wait a bit, and as a developer I like to run fast in my space, so many times I have to do local development first to make sure that it works here and there before going to that sort of environment, a private cloud environment where I have to wait sometimes. And then there's a testing function where you could test the function from here. We type in the triggering event with the post details on the platform, but it's always good to local test first. I would say it's a practice. And that's the details. Okay, now comes to scalability. Here's a runtime build. The amount of RAM, time hours, the amount of time that it runs your cloud function before it dies. It's a good stop breaker in case you hang or run into a infinite loop in a function. And then minimum number is 0. You could set 1 just to make sure it's still at least it runs, but it costs you money. And the maximum number, if you don't specify any, I guess the documentation says it would spawn an infinite amount in instances if you got DDoS traffic or whatever. I don't know. It's a good advice on the documentation to put a maximum number of instances per certain period of time, that sort of thing. So that's one key thing. I guess I would use GCP Cloud Function when I design that function for access with traffic that I'm not too sure when it would need to be scaled up. And of course that ties to a cost variable. Now that goes to another question I had just now. Was I was trying to build a form, like HTML form, to input this ISO t-stop parameter and then so on, which is call that function, generate that JSON, do a post. That requires a front end. So that front end is an HTTP front end also with a form. So I was thinking, should I build that form, the input, into the Cloud Function here, because that's the scalability, right? Rather than using a command line to submit it. But if I do it separately with another URL, then host as another app or function, then if that is not the same, if that doesn't have scalability, then it's no point, right? People access that point and call this function, and that is a single point of bottleneck. So the next step is to see how I could create a form-based environment on Cloud Function also, or maybe another function to talk to this function, and and get to that runtime, that idea of having a front end. There is the front end, this is the back end, and the front end needs to be scalable also. Alright, thank you for listening, and hope that showed something useful on how to formulate an app, a need to use these technologies. It's just a need with a self-contained, immutable, stateless function, which is useful. So, and in the end of the day, we are talking about orchestrating a whole lot of these functions in the cloud, hopefully that they could orchestrate together in a scalable fashion. I think that's the whole idea of public cloud with a so-called microservice architecture. Cheers, bye.